Okay, so we're on to the next part of checking your answers. You need to take the number of your solution and substitute the variable for the variable in the equation with the solution that you have when you solve it. You should get the same number on both sides of the equation. So here's an example problem. Remember, to solve, we want to rewrite 9 plus x equals -5. And then to solve it, you need to remove everything from the side that the variable is on. Here's my variable x. I want x to be by itself. So in order to do that, I need to get rid of this 9. So there is no symbol in front of the 9, which means we can assume that it is a positive 9. And in order to undo that, or to remove it from this side of the equation, we need to actually take it away. So I'm going to subtract 9 from the left-hand side of the equation. And in order to do that on one side, I have to actually do it on the other. So now I have taken the 9 away from both sides of the equation. So 9 minus 9 gives me 0, and I can remove it. I have the x by itself equals, and then on this side I have a -5 and a -9, both negative numbers, and I'm going to combine them because -5 plus -9 makes more -14. Okay, so now I've come up with a solution that says x's value is -14, but I need to make sure I check it. So I'm going to replace or substitute the variable in this equation. So 9, and then I have to put a plus, and then I have a -14. And it's supposed to be a parentheses, sorry. -14 equals -5. Let's see if it does. What is 9 plus -14? Well, -14 is my larger absolute value. If I subtract 9 from 14, I get 5. And I use the sign of my larger absolute value, which is the 14 sign, which is negative. And I get -5 equals -5. And this is my check. So I know now that my solution has to be a -14. So x's value is -14. The next part of your notes, and make sure you write this in your notes. The next part of your notes, we talk about rules for integers. And why are we talking about rules for integers? Well, that's because kids in 8th grade forget the rules for integers. And this is like a review. All right, so we're going to review the rules for integers. When you're adding numbers with the same sign, you want to make sure you just add the two numbers and then use the sign that they share. It's quite simple. This is probably the easiest of the integer rules. But what if they have different signs and you're doing addition? Well, we just did a couple of them like that. You need to subtract the smaller absolute value from the larger and use the sign of the larger absolute value. Okay, so we did this, but we haven't done any subtraction yet. When we actually subtract with integers, we know that we have to change them to addition of the opposite. All subtraction become addition problems. Once we change our subtraction to addition, we can then use these two rules to solve. We use the rules for addition. So we don't have subtraction in our world anymore. We change all subtraction to addition problems, and then we use these two rules. Okay? So if you're going to write those rules here, you're just really going to rewrite them. Same sign, add and use a sign. Different sign, subtract and use a sign of the largest absolute value. And subtraction, change to addition of the opposite, and then just follow the addition rules. Stop the video and write down those notes. Multiplication rules. Multiplication and division are super easy. Not much to remember here. If the signs are the same in the multiplication problem, the answer is positive. Negative times a negative is a positive. Positive times a positive is a positive. But what if the signs are different? If it's a positive times a negative or a negative times a positive, your answer will always be negative. So same signs positive, different signs negative. So what about this thing? This says 1/3 divided by 3/4. This is asking us to remember a lot. This is a very intense little expression here. If I needed to find the value of that expression, I would need to do division of fractions. Division of fractions has one of the complicated rules that we struggle to remember. So there was that little vocabulary song, that keep, change, flip song that I love. Maybe I'll play it for you. We'll see. But what does keep, change, flip means? Well, it actually is how the process of how we find the value of this expression. We keep the first number, we change it to from division to multiplication to multiply, and we flip or we use the reciprocal of the second fraction. So what is that going to look like? Well, keep the first number, 1/3, change division to multiplication, that's easy, 1/3 times the reciprocal, the flip of 3/4. If I turn it over and use the reciprocal or flip it on its head or however we want to look at it, 3/4 becomes 1/3. Now I can multiply. Numerator times numerator, 1 times 4 is 4. Denominator times denominator, 3 times 3 is 9. And I have solved that problem. So there was a lot to remember. I had to remember the signs. The signs are the same, so I got a positive answer. I had to remember the rules for dividing fractions. That's where the keep, change, flip comes in. So, I guess the way I would look at it is a lot of kids struggle with division. And whenever that division sign pops up with fractions, you're going to have to think, oh, this is a complicated problem. I have to do the keep, change, flip. What if you have a problem that looks like this? This actually says 1/3 x equals 3/4. I'm going to walk you through this one. First of all, what is the coefficient of this equation? The coefficient is the number that sits in front of, in this case, the variable. So the coefficient here is 1/3. That means that the variable in this equation is x. What operation is happening between the 1/3 and the x, between the coefficient and the variable? There isn't an operation here, but we know whenever what the coefficient does to the variable, it actually multiplies it. So multiplication is happening right here. I'm going to even highlight that for you. Multiplication is happening between the variable and the coefficient. Okay? So if multiplication is happening there, we need to know what is the inverse operation or the opposite operation of multiplication. Well, guess what? That's division. So let's try to solve this. If I have 1/3 x equals 3/4, I need to divide both sides by 1/3. Well, that's kind of complicated. That brings in the keep, change, flip. But what if I instead just flipped the 1/3 and multiplied both sides by the reciprocal of 1/3, which is 3/1? What does that do to this part of the equation? What does that do to the coefficient? What is 1/3 times 3/1? Because that's going to get that. It makes it very interesting. Remember, what I do to one side of the equation, I have to do to the other. So 3/4 times 3/1 is going to be my equation over here. So 3/4 times 3, or 3 over 1. All right, so now I have my equation set up. But I asked what happens when I multiply this out. I get 3 times 1, which is 3. And I get 1 times 3, which is 3. It's not a 0. I'm going to bring down my x, my variable, because it's still in the equation. And I need to isolate that variable. But did I isolate it? Let's do the other side first. What is 3 times 3? Numerator times numerator is 3 times 3 is 9. 4 times 1 is 4. And this tells me 3/3 times x equals 9/4. Is my variable isolated? You might not think so, but it actually is. 3/3 is equivalent to the fraction 3/3 is equivalent to the number 1. And if we know, because we know our basic operation multiplication facts, that whenever we multiply something times 1, we literally don't change the number. It stays the same. So if we multiply by 1, it's like 1 times 4 is 4, 1 times 7 is 7, 1 times x is x. X is actually isolated now. So literally back here, when I multiplied my fraction by the reciprocal and did the same thing to the other side of the equation, because what I do to one side, I have to do the other, I literally created a 1 to multiply my x. And when I multiply anything by 1, it stays the same. So I literally got rid of it. And is my variable isolated now? It absolutely is. So x equals 9/4. We need to check it. We need to make sure. So we take our equation back up here and rewrite it. 1/3 times 9/4. And let's just solve it and see what it equals. 9 times 1, or 1 times 9 is 9. 3 times 4 is 12. Well, wait a minute. It says it's supposed to be equal to 3/4. Is it? This is a reducible fraction. Both the 9 and the 12 can be divided by 3. If I divide the numerator and the denominator, in this case, by the same number, which is 3, I get 9 divided by 3 is 3. 12 divided by 3 is 4. And look, I get 3/4. 4s are hard to make. Okay? Which it says I'm supposed to have. So guess what? This is correct. X's value is 9/4. I want you to stop the video and fill in your, well, I'm going to stop the video so you can fill in your notes.